Polonium-210 is a radioactive element with the property that every 138 days, the mass of the element in a sample is reduced by half, or its half-life is 138 days. Now they're telling me that A sub 0 represents the original mass of polonium-210. So we don't actually know amount. We have a variable for that. And we want to write a function, A of x. So I'm going to set that up to model the amount of polonium-210 that remains after T days. So my starting value, or my P, is A sub 0. Then I'm going to write 1/2, because this is a half-life formula, to the T over the half-life. So we use the variable T over 138. Now looking back, typically we use T, but I see that in this problem they want X to be my variable that I use. So I'm going to go back and fix that and change that to an X, not a T. Looking through this problem, this 210 is really just telling me about what substance we're working with. It doesn't go into the problem at all. So there is my function, and that is based off the formula. A equals P times 1/2 to the T over H, which is our half-life formula, which goes with the information that we were given. Looking at the second part of the problem, it says if there are 100 micrograms of polonium-210, how much will remain after 60 days to the nearest microgram? So two pieces of information we have here. We know A sub 0 is now 100. That's what we start with. And we know that the T value, which is measured in days, is 60. So plugging those numbers in, I have 100 times 1/2 to the 60 over 138, which when I type it in my calculator to the nearest microgram is 74 micrograms. That should make sense because I do expect more than half of it to be left because we haven't reached the half-life. The 60 is less than the half-life.